And this is Miss Humbert here, and today we're going to be doing Unit 9 Notes 2. So we're talking about monomial and factoring review. So this is stuff that you did in Algebra A that we definitely need to make sure we have a firm handle on before we move on in Unit 9. So first of all, let's remember our rules of exponents. When you multiply like bases, you need to add the exponents. So for example, when you have a to the 6th times a to the 3rd, you're going to add those exponents to get a to the 9th. That's going to become important in this unit. Likewise, when you have a power of a power, if you're raising an exponent to a power, then you multiply the exponents. So you're going to take and you're going to distribute these in, and you're going to multiply them. So 6 to the 1 times 2 is 2, so that's going to be 6 to the 2. A to the 6 times 2 is 12, so that's going to be a to the 12. Okay, again, this is a review, so I'm going kind of quickly, but there always is the Unit 3 resources you can go back and look at. Whenever you raise anything to the 0 power, it's just going to equal 1. So no matter how large the thing is being raised to the 0 power, it's always going to equal 1. Last but not least, when you divide like bases, you subtract the exponents. So when you have a to the 6th divided by a to the 3rd, 6 minus 3 is going to give you 3. So that's going to leave you with a to the 3rd. Okay, so let's go ahead and let's take a look at some of these examples. So we want to simplify these expressions. So we have 4, and this is the same as x to the 1st. When you multiply things of like bases, you need to add exponents. So my 4 is going to stay the same. And then I'm multiplying x to the 1st times x squared. When you multiply those, you need to add the exponents to give you x to the 3rd. Now, x and y are different, so you can't combine them. So that y to the 3rd is just going to kind of stay as is. Then, number 2 should take you all of a second. You see that that entire thing is being raised to the 0 power. So the entire thing is just going to equal 1. Taking a look at number 3. Now, all of those are being raised to the power of 2. What I'm going to do first is simplify underneath in the parentheses. So I have x to the 3rd times x to the 1st. So I can multiply those together, and when I do that, I'm going to add the exponents. So x to the 3rd times x to the 1st is going to give me x to the 4th when you add those exponents. Then y to the 1st, remember if there's no exponent, it's always 1. Y to the 1st times y to the 4th. When you multiply those together, you're going to add the exponents. Now all of that's being raised to the 2nd power. When you take a monomial and you raise it to a power, you need to remember that the coefficient also has an exponent of 1 that you need to distribute your power to. So I'm going to take that 2 and I'm going to multiply it by each of those exponents. So 6 to the 1 times 2 is 2. X to the 4 times 2 is 8. Y to this 5 times 2 is 10. So then 6 squared is the same as 6 times 6, which is going to give me 36. X to the 8th and y to the 10th. So that's my final answer once I have everything simplified out for number 3. Let's take a look now at number 4. So for number 4, we're going to take 4 times negative 7, and that's going to give us a negative 28. And then we have a to the 1st times a squared. You add those exponents and you get a to the 3rd. Then you have b to the 6th times b to the 3rd. Add those exponents and you get b to the 9th. So that's your final answer for number 4. Now, let's take a look at number 5. So I'm just going to write that out a little bigger. So I have 4 a to the 1st, b to the 1st, divided by a to the 1st. Well, let's not even necessarily worry about subtracting the exponents. In general, if I have a over a, 4 over 4 is 1, 6 over 6 is 1, a million over a million is 1. So a over a is also going to be 1. Those are going to cancel out. So all you're left with is 4b for your final answer for number 5. Next, let's take a look at number 6. So now first thing I want to do is simplify this 16 divided by 4. So 16 divided by 4 is just 4. And then I'm going to have x cubed divided by x to the 6th, y to the 7th divided by y to the 4th. So first thing I'm going to do is focus on this guy right here, x to the 3rd divided by x to the 6th. So I need to subtract those exponents. Well, when I do 3 minus 6, I end up with a negative 3. So think about it this way. So I know I have the number 3 as my exponent. Notice where the larger amount of x's lies. That's on the bottom. So when I write my x, I'm going to write it on the bottom. My x to the 3rd power is going to go on the bottom because that's where the larger amount of x's is. Then when I have y to the 7th divided by y to the 4th, subtract those out, and then I'm going to get y to the 3rd, and that's going to be on top because that's where my larger amount of x's lies. All right, now let's take a look at what we learned about with factoring expressions. You're basically undoing multiplication to write it in factored form. So this is that x idea. So let's take a look at this. So maybe your teacher never taught you this. And if you had me, then I probably didn't. So we're going to give you a shortcut for factoring. And that shortcut is when a is equal to 1. And we'll talk about the shortcut more here in a second. But basically, if you have a trinomial, for example, x squared minus 5x plus 6, if this coefficient is 1, once you go through the work of setting up the x, which is -3 and -2, if the coefficient on the x term is 1, you can immediately put that into your factors. You don't have to go through the work of doing the factoring by grouping. You did have to go through that work if it is not 1, which is why we taught it to you the way you did. We're hoping now that you can understand the difference because primarily in this unit, you're going to be factoring a lot of things, but it's just going to be with 1. So we want to make it easier on you. You can go back and use the old method and do all the grouping stuff if that's what you're comfortable with, but we are trying to save you some time here. So besides just factoring trinomials, there's also the option of factoring out the greatest common factor, which is what you need to do for 7 and 8. So if you take a look at number 7, we want to figure out what divides 4 and what divides 12. Well, that's going to be 4. So I'm going to write a 4 on the outside. Then I'm taking each of these terms and I'm dividing out a 4. I can't take out an x because there isn't an x in each term. Well, 4 divided by 4 is just 1, and then you have x, and 12 divided by 4 is just 3. Now that 1x isn't necessary. You could really just write that as 4 times x plus 3. So that is factoring for number 7, but it's just factoring using the greatest common factor. Taking a look at number 8, we want to figure out what divides 3 and what divides 15. And that's going to be 3, and then we're going to take out an x. Because we have 2 x's here, 1 x here. So the smallest amount of x's we can take out of each term is just x. So then we're going to take and we're going to divide each of these terms by 3x. So 3 divided by 3 is just 1, and as we just talked about, you don't have to write that. X squared divided by x is just x. Then -15 divided by 3 is 5, and x over x is going to cancel out. So when you factor out the GCF on number 8, you get 3x times x minus 5. Now let's take a look at number 9, and let's use that new factoring idea that I talked about. So when you set up the x, you multiply 1 times 5, and that goes up top. So you're multiplying to 5, and then you're adding to 6. So what multiplies to 5 and adds to 6? That's going to be 5 and 1. Now I notice that the coefficient in front of my squared term is 1, which means I can immediately go into writing out the factors. Okay, so that's the shortcut. You could go through and do x squared plus 5x plus 1x plus 5 and factor that by grouping. I'm just going to do that real quickly right now so I can show you. And then I end up getting x plus 5 times x plus 1. So you see you get the same thing using either method. So please feel free to use that shortcut method when you're dealing with trinomials. And again, it's only when the coefficient with the squared term is 1. So number 10 is going to be using that differences of squares idea. So when you're doing differences of squares, you set up 2 parentheses. You put a plus in one and a minus in the other. Then you're going to take the square root of the first term. Well, the square root of x squared is just x, and you're going to put that in the first term. The square root of the second term is going to go in the second spot. So that's your final answer for number 10. So this was hopefully a pretty easy review for you, and that does conclude your note video, so please make sure you get your Schoology quiz taken once you are done. Thank you for listening.